This video will cover the topic, Finding Trigonometric Ratios Given a Right Triangle. In this topic, we are given two sides of a right triangle and asked to find three trigonometric ratios based on the side lengths given.
In order to find the length of the third side, we need to use the Pythagorean theorem, right?
Exactly. Let's look at an example. Find the cotangent of theta, the cosecant of theta, and the sine of theta, where theta is the angle shown in the figure. Give exact values, not decimal approximations. The hypotenuse is 11, and the opposite side is 8. Thus, we need to solve for the adjacent side using the Pythagorean theorem. H squared equals a squared plus o squared. Substituting the given values into the equation yields a squared equals 11 squared minus 8 squared, which simplifies to a equals the square root of 11 squared minus 8 squared, resulting in a final answer of a equals the square root of 57.
Okay, now that we have solved for all three sides of the right triangle, we can substitute those values to find the trigonometric ratios, right?
Definitely. Cotangent is the inverse of tangent, thus adjacent over opposite, which equals the square root of 57 over 8. Cosecant is the inverse of sine, thus hypotenuse over opposite, which equals 11 over 8. Sine is opposite over hypotenuse, which equals 8/11.
Okay, I think I'm starting to understand this topic, but can we do another quick example just to be sure?
Sure. Let's look at the example problem. Find the tangent of theta, cosine of theta, and cosecant of theta, where theta is the angle shown in the figure. Give exact values and not decimal approximations.
To start this problem, we would use the Pythagorean theorem to find the value of the missing side, which is the opposite side in this example.
Exactly. Substituting the given values into the equation yields o equals the square root of 6 squared minus 5 squared, which results in o equals the square root of 11. Next, we can recall the trigonometric ratios appropriate for this problem. Tangent is opposite over adjacent, which equals the square root of 11 over 5. Cosine is the adjacent over the hypotenuse, which equals 5/6. And cosecant is the hypotenuse over the opposite, which equals 6 over the square root of 11.
Okay, I think I understand this topic now, but let me quickly summarize just to be sure. We begin by using the Pythagorean theorem to solve for the length of the missing side. Next, we substitute the appropriate side lengths to solve for the given trigonometric ratios.
That's right.